Hello and welcome to Math200 Statistics Online here at Cañada College. My name is Lapuz. In this video, we will go over a problem from section 11.3. This is problem number 1. And here we're saying that you are interested in investigating whether the type of computer a person primarily uses and the type of car they drive are independent. So we have a table below and the results are in survey. So there's a choice of tablet, notebook, or desktop, and then sedan, SUV, or truck. Okay, so what can be concluded at the 0.0 or 0.10 significance level? All right, the first thing that they ask for is find the correct test to use. In this case, we can see the dependence or independence business. So because of that, we are looking for the test for independence. So the test for independence is going to be your choice. Now, the null and alternative hypothesis will be to say that the two categories are independent and dependent. So for the null hypothesis, it's going to be the independent. That's going to be the one that we're trying to reject. And your alternative hypothesis will be that they're dependent. And this was in fact the original claim that we're saying that the type of computer and car are dependent for each person. So we're going to have to find the test statistic, the p-value, and all that stuff. Now, in order to do that, one of the best things to do is to just copy this information onto your Excel file. So, depending on the type of computer you have or anything like that, you can just highlight the whole thing, copy, and then go to your Google Sheets. And for the way we're going to construct this, we will construct an observed table and then an expected table, and then come up with the O minus E quantity squared divided by E table. So I'm going to go here and paste the table that I have. It's hard to create a template for this because the tables can be of different sizes, so I just kind of am pasting it here, and then I'll construct whatever else we need. Like in this case, we will need the expected value table. So I'll call it the expected table. And it's essentially going to be the same table. So maybe I can just paste this information again, except the contents will be different because it'll hold information about what we would be expecting. But then after that, we will also need the actual table that where we're gonna add and subtract, and then or we're gonna subtract, square, and then divide. So that will help us find our test statistics. So this is the table. I call it O minus E quantity squared divided by E, kind of like a table. And then I'll paste that information also. And then I'll clear this because I will replace it with the information that we're going to need. Okay, so now let's go back to the original observed table. To get our expected value, what we need to do is that for each of these cells, we would need the row total, the column total divided by the grand total, which means, well, we have to find the column and row totals. So I'll start with the column totals. I'll say equals the sum, and then open parentheses, and I'll click and drag that small column over here, and then I will get 297. Now, if I take this and click and drag through the table, I'll get the column totals for there as well. For the row totals, I'll get the same thing. I'll say the sum, and then parentheses, and then I'll click and drag the rows, and then I'll press enter, and they ask, would you like to autofill this? And I think we will. So let's just set it at that. Now, we do have this grand total over here. So we want to keep that in mind. That's where we're gonna. That's the total number. Now this is just the the sum of either the row totals or the sum of the column totals, but not both. So let's be clear about that and make sure that's okay. All right, now we will fill in our expected value tables. So for this cell where there's a 94, so that's the sedan and the tablet owners, I will say I'll go to the expected table, and then in that slot I will say equals, and then what I'll do is I'll click on the row total that this has divided by the column total that it has divided by, oops, I'm sorry, that would be a multiplication. Let's start that again. We will go with the row total and then multiplied by the column total and then divide by the grand total. Now technically there's a parentheses around the numerator because we're doing the row total times the column total, and then divide by the grand total. But since this is just going to be order of operations, and you don't really need the parentheses there. Press equal. Now it's kind of hard to click and drag here because the column totals and row totals will move around, and we're not going to be able to get those totals correctly. And then there's some tricks that you can do where you can put some dollar signs in the either before the row or before the column, the I or the 5, or some things like that can simplify your work just a little bit, but I think that might be a little too confusing. So let's just go for each cell. There's only 9 of them. Let's go for each cell where we compute the row total, column total divided by the grand total. So again, I'll say equals, and we're in the first row, and then I'll put the multiplication. We're in the second column, and then I'll put the division, and we'll divide by the row. All right, so I just pressed enter, and then now I'm clicking on that first row last column, or first row third column. I'll say equals, and then the first row total times the third column total divided by the grand total. Okay, that's let me do the rest. Oops, let's make sure that this is correct. So that would be this one. Yep. Divide by that. This times that. Divide by the grand total. Uh-oh, I lost something. All right, let's try that again. So equals, and then this is the second row times the second column divided by the grand total. And then this is the second row times the third column divided by the grand total. Okay, let's keep going. Equals third row times first column divided by grand total. And then equals third row times the second column divided by the grand total. And then finally equals the last row, third row, times the third column divided by the grand total. Okay, so now we have a table of expected values. Next is going to be the computation for the actual test statistic, or not quite the whole computation yet. We're going to add up everything in this table, but we need to create this table first. And this table will have in each cell the observed values minus the expected values squared divided by the expected values. So for the first one, I will say equals, and then I will look for the first slot. Oops, let's put a parentheses. We'll start off with an equals and then the parentheses, and then the observed value minus, and then I'll go to the second table for the expected value, and then I'll close the parentheses. I'll use the caret to say that I'm going to square that, so that's the squaring. the squaring function, and then we'll divide by the expected value again. So that's the expected value slot here. And then if I press enter, I will get this. And here they ask us if we want to autofill. You can choose that because it'll work. I'll not choose it because we want to fill up the whole table. And in this particular case now, we can literally just simply click and drag to fill up the whole table because, because it'll give us the correct values for the observed and expected. And it doesn't seem to be clicking and dragging through the whole way, so maybe I'll do the column first, and then I'll click and drag to do the rows, and then now I have it all completed. Okay, now we want to add all this up. So to add all this up, we'll simply go to the slot that we wanted. So this is our test statistics slot, and our degrees of freedom. And degrees of freedom will be 3 minus 1 times 3 minus 1. There's 3 columns minus 1. And then there's 3 columns minus 1. So that's 2 times 2. So that's going to be 4. And our p-value will be automatically calculated. It uses the chi-square distribution. And it takes a look at the area to the right, since this is a right tail test. And then we're going to input the test statistic, comma, and then degrees of freedom. And that should give us our value, which right now it's empty because we need to fill this up. So to fill this up, we'll say equals, and then the sum, and we're not just looking at a sum of a list, but a sum of a whole two-dimensional table. So it's the sum, and I need to scroll down to the calculations that we just did right here, and I'll click and drag to cover the whole table. And then I'll press enter, and I see that. I get a 9.405. And again, the p-value is automatically calculated. It takes that test statistic, and then it takes that degrees of freedom, and then it gives you the chi-square area on the right. Okay, so let's fill in the rest of this information. Let's move this here and making sure that we can still see what we need to see, or maybe we need to move this a little bit. All right, so looking down at the rest of our problem, our test statistic. Our test statistic is going to be well, it doesn't say here, but this is a chi-square test statistic, and that is equal to the 9.405 that we got. Our p-value is 0.05173, so I'll take that. And then looking back at our original problem, they want to compare this to the 10% significance level. And we see that the p-value of 0.0517 is less than the significance level, which is that 0.10% that we got. So this is less than. And so we will reject the null hypothesis when we have our p-value smaller than our significance level. So we rejected the null hypothesis. The null hypothesis says that they're independent, and your claim was the dependence. So if we rejected the null hypothesis, then we have sufficient evidence to support the claim. So insufficient evidence to conclude the distribution. So I think there's sufficient evidence is what we want to say. There's sufficient evidence to conclude the distribution is not the same. So it's not the same. No, we're not dealing with not the same. The same and not the same is, I think that falls under the category of the test for homogeneity. So we want to look for dependence and supporting dependence. So there's insufficient evidence to say that's dependent. Nope. There's sufficient evidence that it's independent. Nope, that was rejected. And this is the last one. There's sufficient evidence to conclude that the computer and car type are dependent. So let's choose that one. That would be our choice. Okay. All right, I think that's it. I hope that works, and good luck.